Okay, so the first thing I want to do is go over the standard. Talking about Kentucky HSA2, which is using the structure of an expression to identify ways to rewrite it and consistently look for opportunities to rewrite expressions in equivalent forms. Okay, so this is the very beginning of this standard. So you're going to rewrite equations in different forms using some of the properties that we're talking about. It only partially covers the standard. Okay, so let's take a look at our lesson. I'm going to talk about algebraic properties, and the first thing we're going to talk about is numeric expressions versus algebraic expressions. Okay, so numeric expressions look something like this, right? Two numbers with an operator between, so 8 plus 3 would be a numeric expression. 8 times 3, 2 plus 5 times 2 plus 7. And then you could also have 4 plus 2 times 2 minus 4, okay? So those are all numeric expressions. They've got operators between, and they're only dealing with numbers. If you look at algebraic expressions, they're going to be dealing with multiplication, addition, division, subtraction, and all that, but they're going to involve a variable. So you're going to see 2x plus 3, you're going to see 4x minus 3 over 2, all over 2. That's an algebraic expression. A lot of people get these confused with equations. It's not an equation unless there's an equal sign between expressions. So equations can contain expressions. Expressions cannot contain equations. Okay, they're not the same thing. Or you could have like 4x plus 2 plus 5. All right, that's an algebraic expression because there's an unknown variable in it. Commutative property is the first property we're going to talk about, and it's pretty simple. For addition, it's a plus b equals b plus a. It means you can reverse the order as long as the value is the same. You have to be careful with this one. So x plus 3 would equal 3 plus x. You cannot switch the order. If I say x minus 3, this is not equal to 3 minus x, okay? So you can't just swap the two and keep the negative on the right. The negative over here is modifying the 3. So if I really wanted to say that this is correct, I'd have x plus negative 3, and then I know that this is equal to negative 3 plus x, okay? So you have to be really careful on how to rewrite some of these expressions with commutative property. Let's talk about multiplication. It just means a times b is equal to b times a. And I don't know why I wrote parentheses around that. So if I multiply two numbers or two items together, you could even multiply expressions as long as a times b is true and is, well, not true, but as long as you've got a times b and then you reverse the order and multiply, it should be equal. Associative property just means that, well, the way that I like to think about it is you can rearrange parentheses, so grouping symbols. So I've got a plus b plus c is the same as a plus b plus c. So I broke the parentheses around a plus b and put it between b plus c. Works for 3 multiplications in a row as well. So I've got a times b times c, and if I have parentheses around a times b, I can break those parentheses and I can put them around b times c, and I should get the same value. Okay? So it says, determine if the expressions are equivalent. If so, state the property used to show equivalence. Okay, so if I do this subtraction, I've got 8 minus 6, which is 2, and then over here I've got 6 minus 8, which is negative 2. So these are not equal, and this is what I was talking about. They switched the two numbers, but they did not switch the negative, right? If this was going to be true, this would be a negative 6 plus 8. So whatever sign is in front of the number over here, if you're going to use commutative property, make sure that they swap, okay? So over here, I've got 8 minus 6 equals negative 6 plus 8, and this is exactly what I was talking about. 8 minus 6 is 2, Negative 6 plus 8 is going to be also 2. So that's the same thing as 8 minus 6. Or you can think, okay, I'm taking $6 out of my $8 bank account. However you want to think about that, that's going to be the same. And this is associative property. This is associative property. Okay. Oh, can't spell. Over here, all we did was rearrange the parentheses. I haven't changed the order of any of the terms. I've just rearranged the order of the parentheses. So instead of grouping them with x and y, they're grouped with 4 and x. Okay? Okay, so this property would be commutative. Is that true? Do I have them mixed up? Yeah, I got them mixed up. I always mix these up. This is commutative. My bad. Commutative. Let's get that straight. And this is associative. Okay. And over here, it's really similar to the last example. I've just broken the parentheses around x plus 2 and put them around 5 plus x. So this is going to be associative as well. And over here, b times c and a switched. So this is actually commutative property. So I switched the order of an addition. B times c is some number plus a is some number. So I can just swap the two and put the plus sign in between. So this is commutative. And the reason why it's commutative instead of associative is because these parentheses really didn't change what they're around. It's just we changed the order of these two terms. B times c plus a was changed from a plus quantity b times c. All right, so it says prove x times y times z equals z y times x. And so they're asking me to take this, and they actually prove it here. They just want you to talk about the property that's being used. So if you look here, x, y, and z were swapped from the given to right here. So when we swap things, that is commutative property. So we swap those two. And then take a look here, we swap the x and the y. That is also commutative. And this is multiplication. And then lastly, if you take a look here, I haven't rearranged the order. I've just rearranged where the parentheses are. So that is associative property of multiplication. And then down here, I've got something similar. I've got x plus quantity y plus z equals z plus quantity x plus y. And so x plus quantity y plus z, that's your given. And if you take a look here, we didn't rearrange the order. We just rearranged the parentheses. So this is associative property of addition. And then if you take a look here, we rearranged the two options. So I've rearranged x plus y and put it in place of z and put z in place of x plus y. So I just swapped them, so that's commutative. Distributive property. One of my favorite properties, and this is just a rewrite of multiplication, okay? So let's do some of these. All I'm doing is distributing this -4. So I've got -4 distributes to these two terms. So I've got -8x. And this is going to be minus 12y. So a negative times a positive is a negative, so you got to be careful when you distribute things. And there's nothing to combine up there, so we're going to move on to down here. And so I've got 2h minus 4 times 3, the quantity 3h minus 7. So I'm going to distribute this -4 to both terms. So I've got 2h minus 12h plus 28. So 2h minus 12h is going to be -10h plus 28. And I'm done. So you have to be careful when you distribute. Negative times a positive is a negative. Negative times a negative is a positive. And we're done with that one. Over here, pretty similar. Negative distributes. Negative times a positive, that's going to be -8x. -4 times 3 is going to be -12 minus 6. -8x minus 12 minus 6, what's minus 18? Subtract 18. -8x minus 18. And then we just continue to do this. This is pretty fun, actually. 2 times 5 is 10. 2 times 3d is going to be 6d. So 10 plus 6d, and then 7d over here. Add them together. 7d plus 6d is 13d plus 10. And then over here, -3 distributes. So I've got 8 minus 6t plus 15. 8 plus 15. Notice that these are both positive constants, so even though this is a negative, this negative is only modifying the 6. So I'm going to bring -6t down, and this is the same as 8 plus 15. So that's going to be 23. So -6t plus 23. Ooh, fractions. We love those. So I'm going to distribute this 2/3. I'm going to break this down. So 2/3 times 3 over 1 x plus 2/3 times 6 over 1 plus 12 is what we've got going on here. Okay? So the way I like to do this is because a lot of people get confused whenever I start to cross things out. I could show you 3 divided by 3 here, it would be 1. But if you're uncomfortable with that, when you multiply fractions, just remember you're multiplying across, and then across the bottom, and then dividing. So 2 times 3 is 6, so not cross multiplying, not cross like this. If you're familiar with that, and you're like, oh wait, I remember doing cross multiplication, so why don't you do that with fractions? Well, it has to be an equal sign between, and you're usually solving for something. So cross multiplication happens with equations, not expressions. Okay, so 2 times 3 is 6, and then 6 divided by 3. So 6 over 3. X. 2 times 6 is 12 divided by 3 plus 12. And then I'm just going to clean this up. 6 divided by 3 is 2x. 12 divided by 3 is 4 plus 12. So this is 2x plus 16. And I'm good. And then down here I've got a pretty proof that I have to do. Okay, so I'm given this, and I have to get to this over here. So if you take a look here, what they did was they swapped the two terms. Well, what's swapping? That's commutative. And it's of multiplication. Okay? And the reason why it's multiplication is because I've got a parentheses times a parentheses. Anytime there's a multiplication involved, that's multiplication. So it's commutative property of multiplication, even though there's an addition on the inside of these parentheses. The outside parentheses are being multiplied. And then, well, it looks like it's been distributed. So 2 times 3 is 6, 2 times x is 2x, so this is distributive property. And we're done. That's it. That's the lesson. That was pretty quick. I'll upload it. Have a great day. Enjoy this. All of this. It's fun.